Where I Weeknd, the only road that I ever known. Don't know where it goes or what it's all to me. I wreck alone. Where.
Please pause the video and read the problem. It's probably too small for you, but and my face cam is probably blocking some parts of it. So yeah. Anyways, you guys know what to do. Just pause this and read. We are looking for the steady state amplitude in terms of the mass, spring constant, uh, damping constant, and the initial force. So we are given this equation, which is ma plus bv plus kx equals f of 0 sine omega dt, and as you can see, it derives from Isaac Newton's second law, uh, plus well, actually minus the damping force, but two wrongs make a right, so it's plus the spring force. So yeah, and that equals the total force acting upon the oscillator. So as you can see, we are given constants, and we are given three functions of position, position, velocity, and acceleration. So we can use a simple harmonic motion. I don't know what the S stands for in shake head my or SHM, but yeah, you guys get the point. So in the shake head my functions, the position will equal the amplitude times the cosine of omega times t. And then in order to get v, wait, first we can ignore the phase constant for now. So in order to get the velocity, we have to differentiate the position function, and by doing that, since we're deriving it in terms of t, uh, the omega the omega goes out and gets multiplied by the a, and then you guys get the point. And, and then the derivative of cosine is negative sine, so there you go. That's your derivative for x, negative omega amplitude sine of omega t. And then to get acceleration, you would have to differentiate this again. And then if you know the chain rule and the derivative of a trigonometric function, you get the acceleration would equal negative omega squared amplitude cosine of angular frequency times period. So these are your equations for x, v, and a, and now you got to plug them into the function in order to in order to get in order to put these in terms of mkb and f naught. But then yeah, you will use the square root of k divided by m later on. So to, so you can just plug in a cosine omega t for x, and then there you go. It's in red, and then plug in v. So you would get omega a sine b times omega a sine omega t, and then do the same thing for acceleration. So yeah, don't forget the minus, and you'll get that a will turn into omega squared a cosine omega t, and you're left with all this. When I was editing this video, I forgot that the t needs to be lowercase since it's time, not period. So I mean they use the same unit anyways, but yeah, still. But what we can do now is we're supposed to isolate a, and which is the amplitude. So we can just factor out the a first. So and then put it outside the parentheses of this whole function that my mouse is hovering over right now. And then after that, you have to divide both sides by this conglomeration. So so yeah, and then you should get something similar to this. And then after that, now that we have the amplitude function, now you have to put it in the terms given to us: mass, uh, spring constant, damping constant, and initial force of initial driving force. So yeah, we have to eliminate omega because omega is illegal in this case in terms of this problem. So replace it with the square root of k of m as they told us to. And now this is the problem that I got. You got. I mean, this could be different for you guys since I'm not really good at physics, but still, you should get something similar to this. So there you go. This is the study amplitude. So to explain to put the MA plus BV in this problem, the reason why it's in this function is only because originally the driving force only equals the spring force, but then there are other forces that are acting upon it. Like these are not even the forces. Like gravitational force isn't accounted here. So we just have a Soraisic second law, F equals M A, and then we have a dampening force to counteract the driving force. So you got BV, and that's what MA plus BV is. So yeah. Anyways, see y'all in the next physics explainer video.